Well, Natalia, welcome to Trends in AI from Z Alpha, live from NeurIPS 2022. Beautiful sunny day outside.
Indeed.
The last day of the official conference, workshops tomorrow. You had a booth at the expo. How has that been so far for you?
It's been very interesting, quite busy. Had a number of interesting conversations. Also happy to see wide variety of like backgrounds and people coming with all kind of questions. So some of them already know who we are and approach the booth think, oh, that's the famous chip. Some of them have no clue and tell, okay, can you tell me what Cerebras is? So it's
Yeah, so you are director of product at Cerebras, one of the hot AI hardware. Can I say startups, or is it
no,
beyond
it's
that
still
now?
startup, yeah.
Yeah. So can you tell us a bit about your role and what you guys do?
Yeah, certainly. So our company in general has been founded in 2016 with the goal to build a special purpose hardware to make it much faster and easier to train deep neural networks. Since then, it's been an amazing journey. So right now we are selling second generation of our processor and system, and literally I think doing what we set out to do. So we're making it much easier and faster to train large models. So models became much larger since 2016, and it looks like there is no end to that growth. So it's a really good fit for us.
And
for
you
our
guys are known
technology.
for the big chips, right?
Yes, we build the largest chip in the world.
Yeah.
So we are the only one who make production wafer scale processor. So we cut the largest square you can cut out of the wafer and package that as a single processor. Because essentially when the company has started, if you think about that, even back in 2016, it was clear that in order to train large models, you need more compute that can fit on a single diameter processor. So as a result, people need to come up with their algorithms and with the complicated code how to make distributed training work. But if you could only keep all of that compute intact in a single device,
So
then
can you give us some numbers? Like how does your device compare to like GPUs and TPUs?
we have roughly I think 100 times more cores than GPU like A100. We have much more, I think, thousand on the order of 1,000 times more cache on chip, and that's the second differentiation of our processor compared to GPU. First is scale, but the second is also very large amount of on-chip memory, which allows us to be very efficient in workloads with lower physics density, so we can take advantage of sparsity, any unstructured sparsity.
Right.
And we think that that will be critical to make large-scale models more efficient.
And while the NeurIPS show is going on, you guys had some pretty exciting news for like a breakthrough customer, or
Yeah, so
can you tell us
we've
more about it?
announced our partnership with Jasper AI. So Jasper AI is an interesting company in the sense that they've figured out how to build a useful product out of large-scale language models. So they training and fine-tuning models, which enables you to generate new content
Yeah, for like
creative
for marketing
For
purposes.
marketing purposes,
Yeah.
yes.
Yeah.
Yeah. So we are really excited to partner with them because it brings, I think, two worlds together. Our ability to democratize the training of those models from scratch and to make them much better for domain-specific data, and Jasper's AI expertise in specific domain and availability of the custom data they have.
And so we covered Jasper AI in one of our previous shows, and they've gotten a lot of funding, so now they're going to spend it all with you.
We'll see. I think we'll definitely we have a program written out how we would like to see what's feasible with the chips, and hopefully yes, we will let them control much better the models. Which
Yeah, kind of own the whole stack.
own the whole stack.
Yeah.
Yes. Actually, in addition to announcements of our partnership with Jasper, we also announced here that we making it available to the public what we call AI Model Studio. So we partnered with a cloud provider called Scale, that is a cloud provider specializing on kind of specific buildings for large-scale training.
To give like a broader access to your
Give
hardware.
broader access to but I think one of the also differentiation, it's not only access to the hardware, but it's access to the training environment. So if today, let's say you want to leverage cloud to train models, and especially large-scale models, first, good luck with getting multiple instances at the same time. It's not that easy. Second, once you get those instances, you need to figure out how you set up the environment. So you need to make sure that all of the drivers are the right versions, all the software is compatible, all of those instances can talk to each other, and usually you have no control whatsoever about connectivity of those instances. One instance may be here and here, or whatever data centers, and another can be completely different. So it's very hard to run distributed workloads. On our side, we guarantee very kind of tight compute, all connected to each other, and we already provide access to pre-configured trading environment.
Right. And so one of the problems that all hardware startups have is a kind of the uphill battle against the NVIDIA CUDA ecosystem monopoly, you could say, right? So how do you sort of, what's your way to connect with, let's say, developers and to make it more accessible to work on your hardware, apart from providing it, but like in terms of the ecosystem and the software?
Yeah, so we first, from the get-go, we understood that we need essentially to meet users where they are, so we need to integrate at a high level with the most commonly used frameworks such as PyTorch and TensorFlow.
Yeah.
So when people run trainings on our system, it looks very similar how you run on a single GPU. You still have the same PyTorch code, TensorFlow codes, nothing new to learn there. You're right that NVIDIA has a lot of kind of head start, and they have a really rich ecosystem out there. I think we are competing, or our decision is to keep things focused. So as of today, we chose to focus mostly on these large-scale language models because these are the ones which are challenging and requires clusters of GPUs and complex distributed programming on GPUs. So we can support really well those. Not necessarily support today other types of workloads, like we didn't make any attempts to support it for now. In the future, hardware is very generic and support all types of machine learning, but for the software, we decided that we would like to do one thing well and then expand.
So maybe a GPT-4 or 5?
Maybe, yes, but I also think I have so all of those very large scale models, they are good generalists. So they have been trained to show that you can achieve the same performance with the zero-shot learning. So no matter what domain, what language, you can just ask the model and it will respond to you. Which is, I guess, good, but at the same time, if you think about cost of inference, cost of serving, for every single request, you need to spend a ton of money to give you an answer. And in reality, also, like for example with Jasper AI, they have multiple customers, and it's not only for Jasper, for others as well. It might be more practical to have smaller models tuned for a specific domain that you want to work with. So I think in terms of overall progress of AI and steps towards AGI, we definitely want that research. We want to see what's feasible with those generalized models. But in terms of practical applications, in terms of like cost and quality, I'm not sure that things like GPT-4 are the right way to go. Because you might be able to get comparable quality with a smaller model after tuning that model for your specific domain, for a specific language, and it will be much cheaper for you to. Maybe just one comment I also wanted to say. I think one additional topic that we would like to touch and cover is that those large-scale models, and GPT-4 included, they are trained at with the brute force approaches. So they are. I need to double-check the topology of GPT-4. I didn't get a chance yet to look deeply into that. But all the previous generations of those models, they are trained with depth weights. So it's very expensive. It takes a lot of compute. So
yeah, these kind of mixtures of experts, is very important.
Mixture of experts is very important, but yeah, you can think about mixture of experts as a structured sparsity. But in the future, I think that we should be able to build models which can decide which parameters should be updated based on which input. Because it should take different type of compute to make decisions on top of very interpretable and simple inputs, and you can afford and you can spend more compute on examples which are more hard to reason about.
Yeah.
So it's really important to make sure that we can do kind of adaptive models with all types of adaptive quality computations and sparsity. So we don't
Also
throw away
for the energy usage.
for the energy
models,
usage as well. Yeah. So I think as a community, as a, like sorry. As a researcher in the past, I would like to see the community to work on more efficient models, which think about less of brute force methods to train those models, but make them way more cost efficient, energy efficient.
Yeah, the orders of magnitude that we still need to
Exactly.
capture to get to the human level are,
Yes. Yeah, and for us, I think one of the important achievements here at NeurIPS was also we for the first time presented our work on acceleration from sparsity in large language models.
Yeah.
So it was pretty.
So you had a
amazing.
paper on that.
Yeah, we have a couple of posters in tomorrow's neural scaling laws workshop,
Okay.
showing that you can actually sparsify large-scale language models and essentially remove up to 80% of the weights and still preserve the model quality. So that means that your inference becomes like 5 times smaller. You can reduce the cost by 5x and still preserve the quality.
Yeah, because you guys are mainly like your proposition as a product is mainly in the training phase, right?
Right now we are mostly focused on training phase because it's much more hard. Yeah, but we can also take advantage of the same architecture for inference.
Yeah,
So if I think one thing that would be interesting to hear about is what are like challenges you face in the aspect of like manufacturing wafer scale chips, like when it compared to other biggest
I think we are actually thanks to design of the chip, we don't see significant challenges. And the reason is because we made the decision to go with a very homogeneous, repetitive structure of the cores. So our wafer scale engine is a 2D mesh of absolutely the same cores. We have 850,000 cores on a single chip. And if you have defect in one of those cores, we have redundancy built in. We just cross them out and we route around. If you compare that with their traditional chip manufacturing, you have the whole die and you have different areas of the die dedicated to different functions. So it could be cache memory, compute, different types of compute. And if you have a defect in one of the parts, that means that the whole die is like you need to throw it away. For us, because it's all like very small and very homogeneous, we can easily live with defects on the wafers, and that's what we do. So I think, to be honest, none of the 2 wafer scale engines produced, I think none of them are identical, so they will have defects in different
But like
places.
fault tolerance is much more of a kind of built-in.
Yes, so to the software, we still represent the
Are the
2D
hardware
mesh.
designers Russian?
Huh?
Are the hardware designers Russian?
Oh no.
No, because I know that like this sort of fault-tolerant chip manufacturing was like with the Elbrus and all this.
It was, yeah.
Kind of one of the
Yes.
features.
True.
And success with building out the Cerebras supercomputing line, and thank you for joining us on our show here.
Thank you.